Imagine this. You're peacefully sipping your coffee, scrolling through your phone, when suddenly, bam! The ground starts to shake. It's like your living room has turned into a bouncing castle. Your mug spills everywhere, and you're holding onto the couch like it's a life raft in a storm. Yep, you've just experienced an earthquake. But have you ever wondered how in the world the ground beneath your feet decides to start dancing like that? I mean, what makes the earth go, you know what? Time to shake things up. Today, we're diving deep into the ground, figuratively, of course, and unraveling the mysteries of earthquakes. What causes them? Why do they happen? And most importantly, can we stop them? What exactly is an earthquake? Imagine the Earth is like a giant jigsaw puzzle, except the pieces are these massive rocky plates called tectonic plates. And these plates aren't just sitting still, they're always on the move, slowly drifting around like they're playing the world's longest, slowest game of bumper cars. Sometimes, these plates get a little too close to each other. Maybe one plate crashes into another, or maybe they're trying to slide past each other like two clumsy dancers stepping on each other's toes. And when that happens, boom, the stress between them gets so intense that the ground breaks, and all that energy gets released in the form of an earthquake. So, earthquakes are basically the Earth's way of saying, "Excuse me, plates, I need some space." What causes plates to move? Now let's take a deeper dive into why these tectonic plates are always on the move. It's not like they're just bored and looking for something to do. Picture the Earth like a layer cake. You've got the crust on top, which is what we walk on. Underneath that is the mantle, which is like a hot, gooey caramel filling. And way down at the bottom is the core, which is this molten metal ball that's hotter than the surface of the sun. Yes, you heard that right. The heat from the core is constantly rising up through the mantle, causing it to move around like boiling soup. And when the mantle moves, it drags the plates along with it. So, tectonic plates are basically getting pulled around by the Earth's inner heating system. Think of it like this. You're making pizza and you start stretching the dough out. But if you stretch it too far, it rips. Well, the Earth's crust is kind of like that dough. When the plates get pulled, they sometimes tear or crack, and that's when you get an earthquake, the anatomy of an earthquake. Every earthquake starts at a point underground called the focus. This is where the magic, or the disaster, happens. It's where the plates snap or grind against each other. The energy from that break then travels out like ripples in a pond. The point on the surface directly above the focus is called the epicenter. This is where the ground shakes the most. So, if you're at the epicenter of an earthquake, congratulations, you're at ground zero for Mother Nature's dance party. But here's the thing, not all earthquakes are created equal. Some are tiny little tremors that barely make your teacup jiggle, while others are full-on ground shaking, building rattling, movie-style disasters. The strength of an earthquake depends on how much energy is released, which we measure on something called the Richter scale. The Richter scale is basically a way to measure how strong an earthquake is. A 2.0? That's nothing. You might not even notice it. A 7.0? Well, you might want to duck under a table. Types of earthquakes. Alright, so now that we know what causes earthquakes, let's talk about the different types. Yep, transform boundaries. This is where two plates slide past each other. Imagine rubbing your hands together. Now imagine your hands are giant chunks of rock, and when they finally get stuck, all that friction makes a huge earthquake. Classic case? The San Andreas Fault in California. Yup, the one from all those disaster movies. Convergent boundaries. In this type, two plates are crashing into each other like two sumo wrestlers in a match. One plate usually gets forced under the other in a process called subduction. And guess what? Some of the world's biggest earthquakes, like the ones in Japan or Chile, happen this way. Divergent boundaries. Here, plates are pulling apart from each other, like two best friends drifting apart. This happens mostly underwater, at mid-ocean ridges. Fun earthquake facts. Now, let's lighten the mood with some fun earthquake trivia. Did you know that there are over 500,000 earthquakes every year? But don't panic. Most of them are so small that we never feel them. The longest earthquake ever recorded lasted a whopping 10 minutes. That's longer than some people's attention spans. And get this, there are places on Earth where earthquakes happen every single day. Iceland, I'm looking at you. It's like the land of ice and constant shaking. Can we predict earthquakes? We know a lot about how earthquakes happen, but here's the million-dollar question. Can we predict them? Despite all our fancy technology, predicting exactly when and where an earthquake will hit is like trying to guess when your cat will randomly decide to knock over your glass of water. Scientists can, however, make educated guesses. They study fault lines, measure tiny shifts in the Earth's crust, and keep an eye on seismic activity. But at the end of the day, earthquakes are still a bit of a mystery. How to stay safe during an earthquake. All right, time for some practical advice. If you're ever caught in an earthquake, what should you do? The number one rule is to drop, cover, and hold on. If you're indoors, get under a sturdy table and hold on for dear life. If you're outside, move away from buildings, trees, and anything that could fall on you. And whatever you do, don't run outside during the shaking. Buildings love to shed bricks in earthquakes. Oh, and remember to duck under doorways is actually a myth. It's way safer under a table than in a doorway, unless you want to meet the frame face first. Earthquake myth debunked. Myth 1. Animals can predict earthquakes. Well, maybe. There have been reports of animals acting strangely before quakes, but we still don't have hard evidence. Though, if your dog starts running in circles and barking at the floor, you might want to pay attention. Myth 2. You can't have earthquakes in cold places. Nope, earthquakes can happen anywhere, even in Antarctica. The Earth doesn't care about the weather. Myth 3. The bigger the earthquake, the bigger the crack in the ground. Actually, most earthquakes don't leave a giant gaping hole in the ground like in the movies. Those dramatic fissures are mostly Hollywood magic. The future of earthquakes. So, what's next in the world of earthquake science? Well, researchers are working on ways to improve early warning systems. In places like Japan, they've developed technology that can give people a few seconds warning before an earthquake hits. They're also studying the potential for earthquake engineering. Sounds cool, right? It's all about designing buildings that can withstand the shaking. Think of it as earthquake-proofing our cities. So even when the ground moves, we stay standing. And there you have it, the shaky, quaky story of how earthquakes happen. Next time the ground beneath your feet starts rumbling, you'll know exactly what's going on. Just remember, it's not the end of the world. It's just the Earth doing its thing.